turn this on. All right, so let me just do a quick round of introductions, sorry. We'll start with you, Arno. Okay, Arno is our Chief Technology Officer. He holds a PhD and Master's Summa Laude in physics from Switzerland. I didn't know this, but in 2014, he was the Big Data All-Star, as noted in Fortune magazine. We have Kim Montgomery. He's joined by Kim Montgomery, who's a principal data scientist at H2O. She has over 20 years of experience in predictive modeling, a PhD in applied math, and she has been a Kaggle Grand Masters with experience in AutoML and large language model interpretability. And let's see here. Next to her is Ryan Chesler, who's also a principal data scientist at H2O. He's self-taught, and he has earned a double master status in Kaggle for discussions and competitions. He has participated in over 100 different Kaggle competitions, training of more than 10,000 deep learning models. His significant contributions include creating educational content and actively promoting the knowledge sharing and community in data science. Next to him is Mark Landry, Director, Data Scientist and Product at H2O. He's collaborated with PwC projects that won the IAB Audit Innovations of the Year Award, not once, but twice. And he has diverse experience in computer, hardware, healthcare, hospitality industries, and significant roles at Dell. And last, we spoke with Rob at the last panel, but once again, he's one of our senior principal data scientists at H2O, and he has a lot of experience, a lot of knowledge. NFL, I want to talk to him about that. Maybe we talk a little bit about the New York Giants here, but maybe another time. Holds degrees in electrical engineering, and his experience in power engineering and information as well, too. So welcome this panel, and I'll give it off to you, Arno.
Thanks, Tom. Thank you. I hope everyone is having a good time. This is an exciting field. It's never felt more alive, and I've been doing machine learning for 12 years. This is like every week something new is happening. And no one better than the Kaggle Grand Masters to know what's happening and also to know what it actually means, right? By the time you spend 3 months on a Kaggle competition and you win it, you probably know a lot more than most people can even think of what it would take. You know, these people sometimes spend hours a day thinking about, you know, the little details that they missed somewhere or what they learned, or they read other people's work. And so let's see what they can tell us about the recent advancements in LLMs in GenAI. So let me start with Rob. Just in general, maybe tell us a little bit what, you know, let's say for fake generation, right? Data that's generated by LLMs is always fake by definition, but it's somewhat real because it was trained on real data. But wouldn't it be nice to know if it's actually generated by an LLM or not? So what are some techniques people could use here in this space?
Yeah, it's interesting you mentioned that. There actually was a recent Kaggle competition to do that, to detect if text was generated by LLM or by humans. And it's a really interesting field. I don't bore you with all the details. I actually didn't compete in that competition too much. But yeah, models are able to determine it. It's getting harder and harder. I think there are some watermarks in what the LLMs produce that other models can pick up on. But just like most synthetic data or semi-synthetic data, you know, it is becoming more and more advanced, the type of data that you can produce from these LLMs.
Yeah, I'll add to that on the synthetic side. So there is one Kaggle competition I'm doing currently, and I kind of borrowed some techniques from what Rob's referring to. So someone at H2O was second place in the detecting LLM or not, and one of the techniques there that's going to, I think, will be interesting forevermore, I mean, is synthetic data. And something that's interesting about the LLMs is it's just so easy to grab synthetic data, particularly if you have a text problem. It's probably not just refined to that, but you know, they're smart. They can produce good sounding content, but you can go a step further. So something that we've developed in-house now probably about a year ago, LLM Studio, the fine tuning side, you know, where you teach it to speak like something, and you can hear, okay, let's teach it to speak like Donald Trump or Arnold Schwarzenegger or something like that, and it seems like a kind of a party trick sort of thing. But then you get a problem where that's important, and where you can take the nature of the way that a certain corpus is written. There's style guidelines. So that one was an essay. It was a lot of students speaking. The other one is sort of more graduate students asking things, and they're asking a very similar set of questions. And prompt engineering, you can get pretty close, and what we've seen in that competition is that's immediately where people started. So creating a bunch of data that will help augment it, because we didn't have that much to go on. And in most tabular competitions, most of the ones that I've done well in the past, kind of generating synthetic data was usually it was just too obviously synthetic. And your models are going after certain parts, and they're not learning enough. And that's actually true here with prompt generation, but you can go a step further. With fine-tuning, you're mimicking kind of the style of a certain corpus that may or may not be useful for all use cases, but all of a sudden, maybe I was dismissive of that idea for a little while, like, I don't want to speak like Arnold Schwarzenegger, I don't need that. But here, all of a sudden, when you see something and it's deep, thousands of words in some of these things, but they all do have a kind of similar style, and I don't want to sit here and write prompt engineer that all the time, but we can actually get the LLMs to mimic that, and I guess the punchline should be, it helps. The models get better that way, so adding synthetic data, but there's a few data sets that are out there in this one competition, and not adding all of them helps. Some of them are simply way too easy, and the model hasn't learned anything of what you're really after. In this one, it's kind of finding a specific case of PII. So it's been interesting to see how LLMs kind of weave themselves in even to like tabular problems and different kind of things. So I think that's been pretty interesting for me.
Yeah, the generation of data with LLMs is actually really interesting because you can kind of think of it as almost like a retrieval element, because what you're really doing is you're giving back combinations of data that were initially given to it, and so that can greatly expand to the data set that you were originally starting with. And so sometimes it's pulling back out something that you wanted, and it's this really interesting compression of this data set. So you might have to initially pull something from the entire internet to find the one piece that you want, and this is a really efficient way to go and find it and grab it back out and get multiple different variations on it, not just the initial data point that you had.
Yeah, and I hadn't really participated in the contests that involved distinguishing between human and AI-generated text, but I know there are watermarking methods that are interesting in terms of allowing companies to build in differences in the probabilities of selection of words that allows people to identify which text has been generated by a model versus humans, just due to small changes in the probabilities of word selection.
Yeah, so sometimes we hear customers or prospects saying, okay, what is the seed that you use to generate this answer, right? If I change the seed a little bit, how much will it change the answer? And the reality is that sensitivity analysis for LLMs can be quite interesting, quite varied, right? Like if you add one space, suddenly it adds 3 more paragraphs at the end of the answer because it's in that mode. It's not something that's easy for these LLMs to always give the same answer because it didn't know what you wanted, right? So then, is there some kind of an art in prompt engineering, would you say, that you learned from Kaggle, or is that still an art that the world has to learn by themselves outside of Kaggle?
Yeah, I personally haven't learned it from a Kaggle competition, but we were just up here talking about a use case that we worked on, and prompt engineering was huge in restricting to some extent the output of the LLM model. So especially when you're using something like RAG, where you're telling the model, here's a bunch of text that from our documents, and use only this to respond, and it must only use information from that, really allows you to create a model that's a little bit more restricted, and I've found that to be fairly good, yeah.
So when do you use fine tuning? When do you use prompt tuning? When do you use just prompt engineering? When do you do, various things that we just mentioned? Does it depend on the data you have, the accuracy, the time you have, or is there always like for this number of rows you can only do prompt tuning, or for this number of rows there's no way you can do fine tuning? You need thousands. You can't do it with 10 rows or something. Is there some kind of heuristics you learn from Kaggle or from your iterative approaches there, or is it still roughly just try and see what happens each time?
I think for me, you just start with the baseline every time, just prompt engineering, just saying, ask the question of the model, is it capable of doing the thing that you want it to? And then you slowly work through the ranks. And so the evolution that I typically go through is you ask it the question, you do your prompt engineering, and then the next layer beyond that, in my opinion, is typically to do prompt tuning. So instead of using English, you can actually optimize embeddings that get input to the model. And so it's one layer more complicated, but you're actually not changing the model. You're just asking the model a question in its native language instead of English, basically, with math instead of words. And so that's kind of my next order of operations. And then if you have enough data, then you might step up to LoRa or Dora or any of the other number of tricks that have popped up recently. And if that still doesn't work and you do truly have a lot of data, then you might consider fine-tuning or doing some other RLHF type trick in there. But in reality, it seems like most of the time people don't have enough data to do that. So they end up finding that they max out on just getting the best pre-trained model that they possibly can, and then prompt engineering, prompt tuning, maybe some LoRa stuff. And that's my experience so far, at least.
Yeah, same as Ryan, just thinking of what you have and what you're willing to do. So prompt tuning, fine tuning are both going to be supervised techniques. And so you got to put some time in, or if it's auto-generating, kind of like our old predictive cases, which we have some of those. Those are the easiest ones to run through a LoRa model, because if you've collected what the answer is, then you naturally are probably ready for 1,000, 10,000, kind of whatever you need for fine tuning. If your use case demands it too, but all of a sudden you have an extra model to go and deploy every time you want to do that use case. So I think there's a lot of considerations of, what data are you coming in with, and how much do you want to put into refining that. So the prompt tuning is interesting because it seems like it's accelerated fine tuning, so it happens very quickly. So that's an interesting case, but it's a supervised technique, so you're going to still want to be careful that you're not overfitting and things like that, but it learns pretty quickly. But prompt engineering is very simple, it's kind of natural for everyone to do. So.
Yeah, I think I agree with everything said, especially with the order of start with the easiest thing first and then more complicated solution as it's needed. I think that, the foundation models are trained on the entire internet, so they have understanding of things like if you ask it to write like Shakespeare, or ask it to write in a certain voice. If you are trying to get the model, though, to respond in a voice or in a certain format, say a JSON string of certain format, then the model may not know that. Like if I wanted it to write in my voice, I could fine tune it on a bunch of my emails or my documents, and then it would be able to know that. But I'm not popular enough for the model to know me in the foundation model. So maybe that's another case where you might not be able to achieve your goal with just prompt engineering because you need the model to respond in a way that's never seen before.
What is the role of data cleaning in this age? So for traditional machine learning, data cleaning was important, right? You had to know your columns, your features, and now that you have potentially just scans of documents coming in, it probably matters a lot how that is converted to text, no matter how smart the LLM is at the end that will see the text. Or do we have a future of image models looking at the scans and just telling you what the text is? What do you think will happen in the next year or two?
I think the multimodal models are very likely to get extremely strong. They're already getting there, so that's Arno's last one. Is that where it's going? Probably. But as far as data cleaning, there's a couple different things. So, we've seen with some of the Grand Masters of the company that aren't here today, the foundational model, the next stage for us to take is heavy data cleaning. It's there's deduping and things like that, and there's repos out there that have done that for you, some different data sets that have been collected. Some of them have been almost like ground truthed or annotated, however you want to, deduped as best they can, and that's important to save time for one, but just, you don't need 4,300 copies of a certain solution to a Python problem. So, that kind of stuff that can be out there is important to the foundational models, especially for runtime and just time and things like that. So I see that we're paying attention to that. As far as taking everything in, yeah, and that'll be different maybe on the RAG system or something like that, where you have to kind of look at your ability to answer a question to retrieve the right data as a function of the data quality itself. If the model can't see it, if the retrieval model couldn't see it, it can't retrieve it no matter how good the model is. And that's one of the things that we're seeing at H2O we need to continually improve, is how we can read in a classic sense of OCR, but also understanding the documents, tables, charts, and figures and things like that. Your RAG system is not going to understand it if your retrieval model didn't understand it and can't find the right pieces, things like that. And even your LLM too, if it's not portrayed in the right format to the LLM, they're pretty good at getting unconfused almost, but there's still a limit to that. So portraying the information in the best way is important as well. So all different ways in this kind of chain, all the different ways we can use the LLMs, I think the cleaning part, or at least the skills involved with cleaning are important.
I think the data cleaning part is probably the most important, because everyone can just go and download the whole internet. That part is not like that technical of a challenge. The difficult part is filtering it down to actually be what you want. It's been shown in multiple papers basically that you can do with 10 million tokens what would have required way more if you had very noisy data. So people have figured out how to filter it down and get exactly what they want. And that's true of basically every machine learning model, is you need the purified signal for it to learn something. If you have something where your images are always flipped the wrong way, or there's blank images, or there's garbage text that was just left in, it's always going to hinder your model from being able to train properly and converge to what you want.
When you compete, usually you have to use your own resources or Kaggle notebooks or something where the compute is limited. Is there something where you would feel like LLMs of maybe 7 billion or so are optimal nowadays for price performance or availability of hardware, where you can do a lot of good use cases as long as the data is clean? Or would you say, no, you just have to use the best model in the world, even if it's expensive? What is your feeling there?
I think very often the scale, both in terms of parameter and data, is just masking that you have bad data or bad something else. So you can get more out of a bigger model typically, but it's mostly reliant on the quality of the data. And if you do have good signal, you can get it out of something even smaller than 7 billion. You can get it out of 1 billion or below. Like pre all of these LLMs, we had very, very strong models that could do all kinds of complicated things that had less than 100 million, for example. So it's not necessarily that they're just out of the box better at everything. It's just that they've incorporated way more data than everything else. And so if you have good data in your models, you can get good performance out of pretty much anything.
And I think for those that are not maybe familiar with Kaggle, and maybe particularly those that took a look at Kaggle maybe 5+ years ago, like Arno was saying, there's often you're competing in code competitions, and there's a runtime limit, and I think that's practical. I think unfortunately that raises the bar. You have to have code that works in these containers. There's a lot of people sharing, but sometimes it's a little more challenging than just whatever it takes to get some prediction files out. But it's way more realistic for business use cases, I think. And these are the kind of things, it feels like data scientists now is just data engineers with, that know modeling sometimes, that you're fighting with containerization and all that kind of stuff. So I think, and because you have those limits, I think it's true what Arno just said, like the competition I'm paying attention to right now, competing in, but is LLMs, yeah, you have to use a small one. That you can't run the big ones in there. They won't fit. You don't have a time budget, so you've got to run it. 9 hours is a long time until you start really clocking, the LLMs, and can I get VLM in there? No, things like that. So everyone's kind of paying attention to what everyone's done in the engineering side, but I think it's realistic. We've seen customers do that too. Customers that have access to big models, there's still a need for the open source ones because you can flip that in a container much easier. You can lock it down. It's still interesting. So I think for Kaggle, you want the best tool that you can use in your solution. And early on, you want to keep it kind of as lightweight as possible so that you can have room to grow later as you inevitably, people just stack things together and all sorts of techniques.
Yeah, I think if the question is what's the best size model, I think the answer is probably that it depends, obviously. I mean, if you don't need a Ferrari for a Pinewood Derby race and vice versa. But I do think what you touched on about 7 billion kind of being this size that a lot of people are using. If there's a bell curve probably of what the optimal size of model is for you, it seems like it's 7 billion as parameters is what people seem to be using for most problems. So yeah, it really depends, but 7 billion.
Yeah, same thing. I'd say that the bigger models are still generally quite a bit better, especially with higher order cognitive tasks. I've seen papers looking at things like writing summarizations for things like complicated scientific texts, and it's still the case that the bigger models are needed to come up with really good understanding and summaries. So bigger is better, but you're kind of limited when you're doing Kaggle. So as large as you can use within your environment.
And I just want to mention that it's good news. There was another paper that came out yesterday or so that said 1.5 bit is all you need. So it's up, down, or 0, right? So there are 3 different spins in physics. That's all you need. So the activation has to be only up, down, or not activated for every neuron. And so the weights, in quotes, that will be the weights in the end. So the weights are either 0, 1, or -1. And if you train a model from scratch that way, you'll get the same accuracy as a 16 or 32-bit or 8-bit model. So there's hope. Hopefully we'll have even smaller models that will be smarter. And so the key is to keep building more and more of these models to learn from each other. Do you think Kaggle has helped democratize AI? Just like our goal is to democratize AI? I would say so, yes. So would you like to participate in some questions on Slido, maybe, if anyone has questions for the Grand Masters before Cherie will come up to close up the session? I think I have Slido here.
Oh, you do? I can read it off.
8 minutes ago, yes. Okay, go ahead.
Do you have it, or?
Is it this?
Yeah, I go to, where is it?
We need to go to.
I did the starred ones, so. Well, I can read them off. I like this one.
Okay. What are some of your favorite open source projects or libraries related to LLMs outside of H2O?
I would say I'm a big fan of the PEFT library from Hugging Face. It's just for efficient fine-tuning. That's something that gets used all the time, and it's just kind of taken for granted, but that's what allows us to do all of the lower precision stuff and also all of the prompt tuning, LoRa, all of that stuff. It's very important for a lot of workflows, and it allows you to kind of generically apply it to basically any LLM that you have access to.
Yeah, it's been fun seeing some of the libraries. I don't have a favorite. Whatever people give me is good, built on a lot of cool stuff. But it was fun to be in the office, with the pace of development. One, I think something like the PEFT library and Bits and Bytes, one of them wasn't compatible with the other, and Arno and John had to work overnight to try and fit, putting pull requests into these upstream libraries. But that's cool about the open source community is that a day or two later, everything was back working again. So.
Yeah, I think the Transformers libraries from from Hugging Face 2, and then that's built on PyTorch, and then there's NumPy, and like we're on the shoulders of giants, so there's so much open source software out there that we use and kind of forget that it's under the hood. I think I also like using stuff for tracking my experiments, like weights and biases or Neptune. They're great.
Yeah, a lot of those that have been mentioned, and I've been interested in influence functions lately, which try to trace the influence of a specific piece of training data used during the training process to how it affects a response. So packages like track interest me right now.
And I'll add generally again with multimodals, that's kind of what we're paying attention to too. So there's a lot of cool stuff in the multimodal area.
There's another question about how do you generate question and answer pairs for fine-tuning, let's say. Does it even make sense? Will the LLM be good enough to generate you synthetic data that then you can make your LLM smarter from itself?
You could just transcribe this conversation. That'll be a bunch of question and answers. I don't know.
Yeah, I mean, like what we're doing with Data Studio, I think using the LLMs is a really good start because the volume comes out so quickly. So, I mean, I think, yes, the LLMs can definitely get you off to a good start. It's probably your use case depends, so I don't have enough experience to know where the breaking point is there, but certainly in some situations, it's a great start. That's kind of all you need, and it's just neat to see these, I guess, sort of cognitive tasks where we don't have supervised data. You know, that seems to be where the LLMs are really useful. It's low risk in a lot of these cases, so it's a good one to go with. So,
I think in a lot of cases it's easier to come up with questions than it is to know the answers, and that's kind of the premise that it's built on, is you can look at a document and you can say like, what's this, what's that, and it's easy to kind of come up with those pairings, and then you take that back to a new model and then you say, okay, learn this relationship, and then it's able to pull that out and understand the question and answers that you gave it after.
Great. Thank you for your attention. That's all you need. Thank you.
All right. I'm going to pause for a photograph. All right, let's give Rob, Mark, Kim, Ryan, and Arno another round of applause for finishing out strong, a wonderful and awesome day on AI applications and generative AI and so forth. Before I bring up our CEO and founder to close out the session, I do want to just let everybody know, you stick around. After Shree's talk, closing session, we will be having a happy hour. There'll be snacks. And best of all, there's going to be demo stations out there. So if you're interested in the complaint summarizer or the diff tool or something that you saw here today or you had a question, we're all going to be out there. Come and catch us. Look at what we got. You'll be tickled pink because there's some cool stuff out there. So without further ado, to close out this session, I would like to offer the stage to Mr. Sri Ambati, CEO and founder of H2O. Let's hand it off and let's give him a good applause.